All right, guys, we're going to be launching into Chapter 8. We're going to start with Lesson 8283, which is basically multiplying polynomials. Multiplying polynomials. And 8.2 is more like a single term times multiple terms versus 8.3 is several terms times several terms, okay? So we need to start with some vocabulary, and first is first, let's talk about the word monomial. That will lead us into talking about polynomials, okay? So we've used this word, I think, before, and a monomial is a term, so we've used that before, of a number can be a monomial, a variable can be a monomial, or a product of numbers and variables can be a monomial. So there's no adding or subtracting. It doesn't have to have more than one variable. It could be just one. So just a couple of quick examples of what I'm talking about. We could have 2, we could have x, we could have 3x squared y. Okay, so all of those would be considered monomials as long as there's no adding or subtracting going on between them. Okay, so next thing, let's go to it's in our title, the word polynomial. Polynomial. So polynomial, we get a term is the nomial part, but poly means many. So basically it's a sum or difference of monomials. And you're like, okay, how can it be a monomial if it's being added and subtracted? Well, it's a whole bunch of monomials that are being added or subtracted together, okay? Now, we have two special names that you need to know. If we have just two monomials, that polynomial is called a binomial. So it's two monomials being added or subtracted. Oops, no R's. Okay, and then if we have three terms, trinomial, tri meaning three, remember tricycle, so it's three monomials. And again, being added or subtracted. Okay, so again, polynomials include adding or subtracting, sum or difference, okay? All right, so let's go ahead and sometimes the book will just call it like a trinomial is the sum of monomials, and you're like, well, so you can't subtract? And the answer is yes, you can, but remember we can rename subtraction as adding the opposite, okay? All right, so let's launch into dealing with a problem. And so 8.2 is dealing with monomial times a polynomial. So I'm going to show you an example of that problem. So let's put up what it would look like. So we have, let's do negative 3x squared times the quantity 7x squared minus x plus 4. Okay, so I'm going to show you two different methods, and that's a lot of what I'm going to do is show you a lot of different methods how to do things, and then you kind of have to get a feel for what you like to do. So I'm going to show you the horizontal method, and on first, and then I'm going to show you the horizontal method. I can't talk and write sometimes. Yeah, trouble, huh? And then the other guy I want to show you is the vertical method. And then once we get into a polynomial times a polynomial, then I'm going to introduce yet another method. Now, when it comes to a monomial, this math is pretty straightforward. So what we're going to have is the monomial times the polynomial. In this case, it's a trinomial. And what we're going to do is multiply. We're going to distribute that monomial to everything inside the parentheses. So the trick is you got a lot of stuff going on. So we're going to have negative 3x squared. And again, this is not something you want to just do in your head, because that's when we get ourselves into trouble, especially when we're newly doing something. So I get 7x squared. And then I'm going to put in the minus sign, and then I'm going to distribute the negative 3x squared to the x. So then we're going to put negative 3x squared and then times the x. And then we're going to distribute again the negative 3x squared to the positive 4. So I'm going to put in the plus. So whatever sign I see, I'm going to put in there. And then we have the negative 3x squared times the 4. And now we just remember our rules from chapter 7. So negative 3 times 7, so I often kind of just trail along. Negative 3 times 7 is going to give me negative 21. And then we have x squared times x squared. So we add our exponents, and that gives us x to the 4th. And then we look at the next problem, and notice that you have a negative times a negative times a positive. So two negatives make a positive. So we're going to put a positive here. Bink. And then we're going to multiply the 3, since we've taken care of the sign. The 3 times the x is going to give me a 3. And then x squared times x gives me a total of x cubed. Okay, now we look at signs again. And we've got a positive times a negative times a positive. So I have a negative left over, so I write down subtraction for negative. And then I'm going to multiply the negative 3 times 4, or now, I'm sorry, I already put my signs in, so it's kind of sign gender neutral, right? We get 3 times 4 is 12, and then we get x squared. Now, what you notice is we don't have any like terms, right? Because none of the variables have the same exponent. So that's how I would solve the problem that way. Vertical method is you take the longer polynomial and put it on top, and the shorter monomial or polynomial on the bottom. So same idea that we would do with whole numbers, right? And we're going to do the multiplication, but we're just going to do it from the end, just like we would do with normal multiplication. And we go from the end and we'd go upwards. So first things first, I'm going to multiply negative 3x squared times positive 4. So that's going to give me negative 12x squared. Then I'm going to multiply the negative 3x squared times the negative x. So the signs are the same, so I get a positive. And then I get 3, and then x squared times x is x cubed. Then I'm going to multiply the negative 3x squared times the positive 7x squared. So that's going to be negative 3 times 7 is going to give me a negative 21. X squared times x squared is going to get x to the 4th. So it's a little bit more compact. The work, you're doing more of it in your head. You're visualizing it one problem at a time. Okay? So let's talk about what if it's not a monomial times a polynomial? What if it's a polynomial times a polynomial? So how's that going to be different? So let's go on to the next page. And we're going to have a problem like this, guys. So we're going to do a binomial times a binomial. Now I'm going to tell you right now, you probably have your mom or dad or older brothers or sisters or grandparents who are going to talk to you about, oh, you just FOIL that. And you're like, FOIL? And foil, that's some silvery thing that we wrap food in. Okay, but it's just kind of a mnemonic device about the order that you do things. However, we don't need to do that. We've got horizontal method, we've got vertical method, and then I'm going to introduce you to the area model, which I call the matrix. Don't ask me why, I just do. Which is kind of unfair because you're going to study about matrices in Algebra 2, so I apologize in advance for that. So again, I'm going to show you now 2 methods, and then we'll add the third one in. So let's start with the horizontal method. And we are going to do our distribution, and we're going to do it in an orderly fashion, okay? So let's go ahead and rewrite the two problems next to each other. Okay, and then what I'm going to do is I'm going to multiply everything in the second polynomial by the first monomial in the first polynomial. Oops, that's a lot of words. So I'm going to multiply 2x by the 4x squared. And then I'm going to multiply the 2x by the negative 7. So the signs are different, so I'm going to put in a negative sign. And then I like to put my signs in first. It really does save a lot of issues. Okay. Now I'm going to multiply everything in the second polynomial by the second term in the first one. So I'm going to multiply everything by 3. So 3 times 4 is going to be a positive. And then we're going to get, 3 times 4x squared. And then we're going to get a positive times a negative. I don't know why I wrote that sign in orange, but here we go. We'll do it in black. And then we're going to multiply the 3 times the 7. So notice I take care of that sign first, and then I just start doing all the math. So let's see, 2 times 4 is 8. X times x squared is x cubed. Negative 2 times 7 is negative 14, and x times nothing is x, right? And then 3 times 4 is 12, and then we have the x squared. And negative 3 times 7 is negative 21. Okay, now, you sometimes will come into a problem, and so what I notice is that my numbers are not in what's called, I'll write underneath here, descending degree order. And descending degree order talks about the exponents on like bases go from greatest to least. That's descending. Now, there is a possibility of having two variables, so you can only descend one of them, and generally speaking, the other one ascends. So you'll see some examples of that. So I'm going to have to do a little rearranging because I have an x cubed term, then followed by an x term, then an x squared term. So I'm going to swap out the x term and the x squared term. So then I have plus 12x squared. Notice that the sign in front of the term goes with it. Then minus 4x, and then minus 21, and that's your final answer. Okay, now the reason why that happened is that if you look at your second polynomial, it went from a power of 2, or an exponent of 2, or a degree of 2, to a degree of 0, meaning there is no variable on the 7, and that's why that happened. Okay, all right, let's look at the vertical method. So it doesn't matter since they're both the same length. We're going to put one on the top and the other one on the bottom, and it doesn't matter. So I'm going to put 4x squared minus 7 on the top, and I'm going to do 2x plus 3 on the bottom. So again, I'm going to multiply 3 times negative 7 is negative 21, and 3 times 4x squared is going to give me positive 12x squared. Now, here's what's interesting when we use this method. When we use this method, we need to make sure that we line up numbers in like columns. So in other words, if I have two answers that have x's, then I line them up underneath each other. That means that when I get this next guy, 2x times negative 7, that's going to give me negative 14x. Well, I don't have an x term, so I'm going to place this where it should be, which would be between the x squared term and the constant. Okay? Then I'm going to multiply 2x times 4x squared. So 2 times 4 is 8. X times x squared is x cubed. So that's going to have to go out in front of the x squared. Okay? Then I just add them up. Now in this one I have nothing to add because I didn't have any like terms. So I get 8x cubed plus 12x squared minus 14x minus 21. And you should notice that that's exactly what we got before. Okay, so let's talk about the area model, which I can't help myself. Some people call it the box. I don't know why I call it the matrix. I just do. Maybe I watched the Matrix movies too much when I was younger. So what you're going to do is you're going to create an area model. So you're going to look at your how many terms you have in each of your polynomials. And in our particular example, we have 2 terms and we have 2 terms. So what we're going to do is create a 2 by 2 box. Okay, that means I'm going to have a big box. And I'm going to have cut it into a 2 by 2 box. So 2 on the width, 2 on the length. And I'm going to create 4 boxes. Now I'm going to take my polynomials, so in this case binomials, and I'm going to write one polynomial on the left side, on the outside of the box, and then the other polynomial on the top, outside the box. So it doesn't matter who goes where. Honestly, does not matter. Okay, so I'm going to do the 2x squared is going to be vertically. Now you got to make sure that you include the sign. And then we're going to have the 4x squared minus 7. So only one monomial per box. So what I'm going to do is the math up at the top. So for this box, and it doesn't matter whether you go side to top, top to side. But this box, if I wanted to calculate the area, it would be 4x squared times 2x. Okay? So that answer is going to be 8x cubed. Okay? And then we're going to have the next one's going to be, we'll just keep going this way. Let's see. So this one's going to be negative 7 times 2x. And that's going to give me negative 14x. And then the next one is going to be 4x squared times 3. And that's going to give me positive 12x squared. So I put the signs in because they're going to play a role when I write out my final answer. And I didn't put the first one in because he's the big guy. He's going to be out in the front. And then we're going to have negative 7 times 3, which is going to give me a negative 21. Now what I'm going to do is take those black answers and I'm going to put them in descending degree order. So 8x cubed plus 12x squared minus 14x minus 21. Same answer we got every time. Now I am going to share with you that there are some patterns that happen when I don't have a skipping of an exponent. Okay, so that's going to come up on our next page. Now, regardless of what the problems look like, the directions are going to be the same. Bottom line, you're just going to be asked to simplify. Now, I'm going to start with a monomial problems, but I'm going to show you how it generally shows up, especially when it comes time to the practice or the placement test. So let's say we have 2p times the quantity negative 4p squared plus 5p. And then we're going to have minus 5 times the quantity 2p squared plus 20. Okay. So I'm going to be multiplying 2p times each of the terms in the binomial behind it. So 2 times negative 4 is negative 8. P times p squared is p cubed. Then I'm going to multiply 2p times positive 5p. That's going to be a positive 2 times 5 is 10. P times p is p squared. Now, this is the one you got to watch out for. This is in 5, it's negative 5. So we're going to distribute a negative 5 times 2p squared. So that's going to give me negative 10p squared. And then we're going to multiply negative 5 times 20. That's going to give me negative 100. Okay, now all I need to do is look for any like terms, and then I'm going to combine them together. And like terms mean they have the same variable with the same exponent. Ooh, look at that. Those guys cancel each other out. They're opposites, right? And opposites always equals 0. So they cancel each other out, whoop, and you're left with this as your answer. Negative 8p cubed minus 100. Okay. Now, we can take that problem slightly further. I think I can fit it in here. And we could create an equation that we needed to solve. So we have 2a times the quantity. So you might actually see the directions on this one would say solve. So we'll have 2a times 5a minus 2. We're going to add to that 3a times the quantity 2a plus 6 plus 8 equals, and we're going to have a times the quantity 4a plus 1, and then plus 2a. Oh no, sorry, minus 2a times the quantity 6a minus 4. And then we're going to get, I think that is a plus. Yeah, let's make it a plus, sorry. And then we're going to have plus 50. Woo-wee, we got a party going on over here. Okay, so here we go. We're going to multiply 2a times 5a. That's going to give me 10. a times a is a squared. We're going to have 2a times negative 2. 2 times negative 2 is negative 4, and then there's an a. Then we're going to multiply 3a times 2a, so 3 times 2 is positive 6. a times a is a squared. Then we're going to multiply 3a times 6, and that's going to give me a positive 18a. And then we have just the 8. And then we're going to have that equal. And then we're going to go ahead and multiply a times 4a, which is going to give me 4a squared. And then we're going to multiply a times 1, which is going to give me an a. And then we're going to multiply 2a times 6a. That's going to give me 12a squared. 2a times negative 4 is going to give me negative 8a. And then we're going to have plus 50. Okay. Whew. Okay, so what we're going to do is simplify as best we can each side. So a squareds go together. So we have 10a squared plus 6a squared is 16a squared. And then we have negative 4a plus 18a is going to be a positive 14a. And then we have that 8. So we're starting to get smaller. And then over here, we're going to add up our a squareds, and we get 16a squared. I know you're starting to sweat going, how on earth am I going to work with a trinomial like that? I don't know. We'll get there. A take away 8a is negative 7a, and then we have a plus 50. So we want to get all the variables on the left, and we want to get all the constants on the right. So we're going to subtract 16a squared. Blissfully, they cancel each other out. Whew. So then I'm going to add 7a to both sides to get the a's together on the left, and I'm going to subtract 8 from both sides to get the constants on the right. So 14a plus 7a is 21a, and then 50 take away 8 is going to give me 42. Divide both sides. Okay, let's do that in red. Divide both sides by 21, and we get a equals 2. And then you could substitute that back in and test it out. But, ooh, see, this is the kind of stuff we get to do now that we have this stuff in our heads. All right, let's do a couple of problems. I'm probably going to have to go on another screen. But that's how important this stuff is. So we're going to do a polynomial, a binomial times a binomial, like we did in the illustration of the methods. So we have a 2 terms by 2 terms, so we're going to create a 2 by 2 box. Doesn't matter who goes where, but we have one term including signs above each of the boxes and to the left of the boxes. And then we just do the math. So this guy is going to be 2x times x, which is going to give me 2x squared. And then we're going to have 3 times x, which is just going to give me 3x squared. I mean 3x, sorry. Positive 3x. And then we're going to do 2x times 5, and that's going to give me a positive 10x, and then we get 3 times 5, which is going to give me the 15. Now, do you notice something kind of interesting? Do you see where the like terms are? Okay, so this is what I was talking about. If you have polynomials that are in descending degree order and no skipping of any exponents, look on your diagonals. Magic! That's where you're going to find like terms. So when I write out my polynomial, it kind of is in a Z way. Boop, like that. Okay? So I'm going to erase that since it's covering everything, right? And we're going to get 2x squared upper left, and then we're going to combine our like terms on the diagonal, 13x, and then we have plus 15. Okay? Now, you can use any method you want. I'm going to keep illustrating the area model because this is probably the one most people have not seen before. So, okay. So for this last one, I'm going to give you the doozy. Okay? And so here's your doozy. We're going to have 2y squared plus 3y minus 1, and we're going to multiply it by 3y squared minus 5y plus 2. So what makes this a doozy? It's a trinomial times a trinomial. Doozy number 1. Doozy number 2, we have positives and negatives. Okay? Doozy number 3, trinomial, trinomial. I don't know if I already mentioned that. So this is going to be a 3 by 3 matrix. So I'm going to make my box a little bit bigger. And we're going to have 3 by 3. Now, it doesn't matter who goes on the top and who goes on the left side. That doesn't matter at all. Make sure you got your signs. Now, you don't have to write the problems out in the matrix, but I am doing that right now until we get used to where the answers are coming from. So we're going to have 2y squared times 3y squared. And what's great about the matrix is you can do the math any order you want to. And that answer is going to be, just change up colors, 2 times 3 is 6, and then we have y squared times y squared is y to the 4th. In fact, I'm going to go down in columns this time. So the next problem would be 2y squared times negative 5, and that's going to give you negative 10y squared. And then we have 2y squared times 2, which is going to give us, and again, remember to include the sign, positive 4y squared. Okay, now let's go down the 3y column. We have 3y times 3y squared, so that's going to give me 3 times 3 is 9, so positive 9. Y times y squared is y cubed. Okay, and then let's see what else we get. Oh, you know what? I messed up, didn't I? Yes, I did. I was looking at something that didn't quite look right. Over here, middle guy in the first column, that's not a 5, it's a 5y. So that's going to change my exponent from being a 2 to being a 3. That makes more sense now, and you'll see in a minute why I'm saying that. Okay, and then let's see, we've got 3y times negative 5y. That's going to give me a negative 15y squared. And then the last one in this grouping, we've got 3y times 2. So notice I'm not using the positive signs in here, so if you don't see a sign, it's a positive number. And that's going to give me a positive 6y. But I always want to put it in the answer. Okay? All right, we got the last column. This is the easy one, right? Negative 1 times 3y squared is going to give me negative 3y squared. And then we're going to have negative 1 times negative 5y. Two negatives make a positive. So we're going to get a positive 5y. And then we're going to have a negative 1 times a positive 2. And that's going to give me a negative 2. Now look at this. Are you ready? Look in your diagonals. Ready for it? We've got 6y to the 4th. So I'm going to write him down. He's the only guy there. Now, look at this diagonal. You've got y cubes. You have a negative 10y cubed and a positive 9y cubed. So I'm going to write that out. So a negative 10y cubed and a positive 9y cubed. Because again, this is our first time doing this. I want to make sure you understand. Now I'm always going to write a plus here. I'm going to change my color out. Look on this diagonal. Y squared, y squared, y squared. Why does this work? It's because my polynomial's descending degree order, not skipping any exponent. So let's see. That's going to give me a 4y squared minus a 15y squared minus a 3y squared. All right? Oh my gosh. Look at this guy. Right here. Another diagonal. We got some more like terms. So let's see. We're going to write plus, and then inside it's going to be a 6y plus a 5y. And last but not least is the poor little old negative 2. And then we just combine everything up that we need to. So we have 6y to the 4th. Negative 10 plus 9 is going to give me a negative 1, which I'm not going to write the number, y cubed. Over here, oh my goodness. So let's see, we have negative 18y squared plus 4 is going to give me a negative 14y squared. Then we're going to have a 6 plus 5 is 11y, and then minus 2. There you go, my friends. So again, you can use any method to solve this. Try the area model and see how it goes. All right, we'll talk about this in class together. See you guys later. Bye now.